All right, so we're getting those in a slope-intercept form. 3y equals negative 4x. Y equals negative 4 thirds x. So everybody should have been able to do that, no problem. This is just graphing two lines. We did 2 units on graphing. The only new thing that you learned is where those lines cross is what we call the solution to the system. Because that point, 3, 4, is an x and a y that is on both lines. All right? 3, negative 4. Sorry. 3, negative 4. Right? Everyone can do that, yes? Okay. Now we're going to do some stuff. Okay, pick a number. Too big. Come on. Huh? 7 would be good. 1 won't work because anytime you multiply anything by 1, it doesn't change. So we've picked 7. Multiply both sides of the second equation by that number. Okay, so the second equation is 5x. So we're going to have 5x minus 3y equals 27. Now if I multiply all of that by 7, what do I get? I get that, yes? Everyone's okay with this, right? Now, you guys are smart kids. If I solve this for y, so if I get y by itself, watch what happens. (21 divided by 189). What did I get? I should shrink this down 1. What happened? He waited for 30 people. Yes, Carlin? I got the exact same thing. What does that tell us? What did I do here that ended me up here? Don't worry, it's not like it says right on the page what I did there. I don't expect 30 of you to figure that out. I know you know, Carlin. I'd like one of the other 29 brains in the room to put it together. Fortunately, I have 80 minutes with which to wait. I multiplied both sides by the same number, and I got the same equation, didn't I? Okay. So, now, what does that mean for us? Multiplying both sides of a linear equation results in, what did it give us? Is this, does what I just made green look like either of the equations in my original system? Is anything there in green any of the numbers that were in my original system? No, it isn't. So that means I can change the equations in my original system and not affect the solution. Does everybody understand what I am saying? That is the key point from here. Multiplying both sides of a linear equation results in the same graphed line. It changes the look algebraically. It doesn't change it graphically. Is everybody with me? Okay. So, changes the numbers, not the graph. Which means, would it change my solution? No. Everybody cool? I can change the way the equations look and still get the same solution. Go on to the next page. This page says to add these equations. So if I add these equations, what do I get? Can I put 4x with 3y? No, what do I have to do? I got to keep the like terms together, right? So what is 4x plus 5x? 9x. What is 3y plus negative 3y? 0y. And what is 0 plus 27? Okay. What happened when we added those? I'm going to do two things. What happened algebraically when we added those two equations? Excellent. One variable was eliminated. And I'm using the word eliminated because we are doing elimination right now. All right. Now, I also said to graph this equation on the grid, right? So let's graph this. If I were going to graph this, I would divide both sides. Because it only has one variable, it can't be a diagonal, right? It's got no y values. So I would divide both sides by 9, and I would end up with x equals 3. Right? So algebraically, we lost a variable. What happened graphically? Well, let's go find out. Where on this graph is x equals 3? How do I find x equals 3? 1, 2, 3. And if x is always 3, it's a straight line, isn't it? And please notice, when I eliminated that y value, the line that it gave me the x value. That was my answer. Everybody cool? So graphically, what happened? We got a vertical line through the solution. Everybody with me? Now, what would happen if I subtracted these? What would 4 minus 5 be? I know it's a tough question, guys. Just take your time. Get your calculators if you need to. 4 minus 5. Negative x. 3 minus 3. And 0 minus 27. Negative 27. If I wanted to graph that, what should I do? Move the y. You would move the y? The y is already positive. You're going to need to do something with the y, but should you move it? You shouldn't move it because it's positive. We're going to move the x. 6y equals x minus 27. Then we're going to divide by 6 and get y equals 1/6 x minus 27 over 6 is a little weird, right? It's 9 halves. And if I were to graph that, I would go to 4.5 with a slope of 1/6, right? Negative 4.5 and a slope of 1/6. So let's go up to here. 1, 2, 3, 4.5. And a slope of 1/6. Up 1, 3, 4, 5, 6. What do you notice about that line? It also goes through the solution. So what does that tell us? We can multiply, and it doesn't change the solution. We can add or subtract, and we still end up with what? Lines that go through the solution, right? Now, of all the things we did, add, subtract, multiply, and of course, if we multiply, divide works too, right? Of all those things we did everything on the graph still worked, right? We always went through the same solution. But one of those options helped us algebraically. Which one? Which one of all three things that we did makes it so we can actually solve this system without ever graphing it? Because there's a reason we can't solve it, right? This was our system. Why can't you tell me what x and y is right there. What about that makes it impossible? It's the same problem we were having yesterday, and we had to use substitution for it. Why can't we solve that? And if that's too complicated, I'll ask you this. Why can we solve this? This one we can do. This one we can't. Why? The top one only has one variable. You can't do algebra when you have more than one unknown. So one of the three things we did helped us solve this. What did we have to do before we're able to move forward here? We have to get rid of a variable, yes? And which one of these three steps got rid of a variable for us? Was it the multiplying? Multiplying got rid of a variable for us. There's the multiplying. Did I lose a variable? Nope. When I added them, did I lose a variable? I did, didn't I? And when I subtracted them, did I lose a variable? No. So only this step did any good for us, right? Because a variable was eliminated. What was special about here that allowed me to eliminate a variable? What do you notice about this particular step that allowed me to do something? You can talk to your neighbor if you need to, but it's sitting right there in front of you. Why did the y's disappear? Carlin? Because they had the same coefficient but opposite signs. When you add them, you get 0, and they disappeared. Now, knowing that, let's look at this situation. And the first thing I want you to do is tell me another equation that will have the same solution. So you know that we can add, subtract, multiply, and divide. We can do all kinds of math here. What is the easiest way to give me another equation that will have the same solution? We just did it 3 times. Somebody should be able to tell me something I can do that will get me a third equation. Carlin. I could add the 2 equations together. So 1, I could add them. And that would give me, what's 3x plus 1x? 4x. What's 2 minus 1? Plus 1y. And what's 18 plus 1? 19. That would work. What else could I do? Jazri. I could multiply one of them. Which one? You could multiply the bottom one. By what? 2. Okay, that would get me 2x minus 2y equals 2. Everybody cool with that? Okay. Is there another thing I could do? I could subtract them. What's 3x minus x? 2x. What's 2y minus y? Plus 3y. And what's 18 minus 1? 17. And I can't divide here because there's no common factors, right? But if there was a common factor, I could also divide. Now, what one of those 3 would be helpful to us? The second one? Why would the second one be helpful? That would get rid of 2y, wouldn't it? Because I'd have 2y, and I would get rid of the y. Does everybody see that? Now, as always, that is why this works. Okay? Let's actually put it into practice. Turn the page over to 238. This is the basic stuff. But there's one thing in there that's not written down. This is going to be our first step. Add or subtract to get rid of one variable. What if there isn't a variable that matches up? Carlin pointed out that if they're the same number, we can do this. What if there isn't one that's the same number? What am I allowed to do to change the variables so we can work with it? We can multiply. All right? So to solve by elimination, before you can do this, you might have to multiply to get the coefficients to work. Maybe. So let's look at this very first one. Is there a coefficient that is the same but has an opposite sign? Which one? Y or X? Y. So if I put these together by addition, the Y is going to disappear, isn't it? What is 3x plus 4x? 7x. Negative 5 plus 5 is 0, so it's gone. And what is negative 9 plus 23? 14. Now, that's the first step. In yellow, we add or subtracted, right? And that got me that. Now, the second step, in blue, solve for the remaining variable. How do I solve this? I divide by 7. So what does x equal? 2. There's the second variable. Now, just like in substitution, I know half my answer, don't I? So what do I do with that? With that 2. What does that blue statement tell me? What does that say in English? If you were to read that blue line to me, what would you say? X equals 2, which means that every letter X is what? What do you see there? X. What do you see there? X. I can work with either one of them. And what are those X's? 2. So all I do then is I take this 2 and I put it anywhere that I see an X. How many times do I have to do it? All the times there's an X or once? If I do it once and I've done it right, it's going to give me the answer, isn't it? Is there a way to check at the end if I did it right? Yeah, there is. So X is 2. Which one of these do you want to work with? Does it matter? No. So you choose which one you're going to work with, plug 2 in, and find out what Y is. I, of course, am going to do both to show you that it works with both. And once I've done that work, I find X is 2 and Y is 3. Now, I've done this about 1,000,000 times. I am 100% satisfied that I have the right answer. Is there something you should do to make sure you have the right answer? Put it back in, right? 3 times 2 is 6. 5 times Y is 15. Is 6 minus 15 negative 9? Yes. 4 times 2 is what? 5 times 3 is what? Is 8 plus 15, 23. So did we do this right? Yes. Is everybody cool? Do I care if you use substitution or elimination? No. I will ask you that you know to know both, because as we go further, you will notice that in some places, substitution works better. And then in other places, elimination works better. So it's good to have both available to you. Does everybody understand what I'm saying? Okay, so let's look at the second one. This is the key point. Sometimes we may need to multiply one or both to get elimination to work. Will elimination work in this set right here? Right now, will it work? No. Why? Because there's no coefficients that are the same, correct? With opposite signs. How could I make them be the same with opposite signs? What could I multiply one of those by? If I multiply the top one by 2, then I'm going to get 2x minus 4y equals 14, correct? And what do you see right there? There's my elimination, right? So all I do is add them together to get rid of the y. What's 3 plus 2? 5x. What's 1 plus 14? 15. What does x equal? 3. Now, Daniel, what can I do with every x I see? Make them into a 3. Well, here's a single x all by itself. That's a pretty easy one to work with, right? Yeah. So that guy is going to become 3 minus 2y equals 7. Right? Solve it. Move the 3 over. Negative 2y equals 4. Y equals negative 2. So now I have an x and a y. So my answer is 3, negative 2. Do I check it? Yes. I know I don't need to check the first one, do I? Because I just did the first one. So I just got to check the second one. What's 3 times 3? 9. What's 4 times negative 2? Negative 8. What's 9 minus 8? Is it supposed to be 1? So did we do it right? Everybody good? All right. What's weird about the second one?
Please excuse the interruption.
I will.
Could all grade 9s, last names starting from A to C, please report to the cafeteria. All grade 9s, last name starts with A, B, or C.
None of you are grade 9s masquerading as 10s, are you? Okay. I know I have one in one of my other classes. All right. What's weird about the second set? The first thing is obvious. It's the same as the first one. There's neither one of them is the same, is it? So I got to change them both, right? Or I got to change at least one of them. But you'll notice that the numbers are weird, right? So I need somehow to get either the x's the same or the y's. What's the easiest way to do that? I'll show you an example. 3/5 plus 4/7. How would you have done that back in grade 3? What's the easiest way to find that common denominator? Multiply that guy by 7 and that guy by 5, correct? So what would be the easiest way to make 2 and 11 the same? Multiply the 2 by and the 11 by. Would that work? Okay. How would I do 3 and 2? Same thing. I would multiply the 3 by 2 and the 2 by 3, right? Does it matter which one I do? As long as I eliminate. But let me give you a small piece of advice. Notice how one of these is positive and one is negative? So it's probably best if I work with the y's, right? Because that's one less step. So what would I multiply this guy by? 2. What would I multiply this guy by? 3. And that gives me a whole new set of equations that look different, but aren't different. Does everybody understand? What does that give me for the first one? 4x equals 40. And what does it give me for the second one? 33x plus 6y equals -3. Now, do I have my magic combination? So the y's are going to disappear. What am I going to get? What's 4 plus 33? 37x. What's 40 minus 3? 37. What does x equal? 1. As soon as I have x equals 1, where can I put that 1? Any x I see. Which one do you want to work with? Does it matter? Does it matter? No. I personally would work with the top one because the numbers are smaller, but that's just me. What goes in for x? Two times 1 minus 3y equals 20. 2 minus 3y equals 20. Minus 3y equals 18. Y equals -6. Now, what is my ordered pair? 1, -6. And I check. Do I need to check the top one? No, because I just did the top one. So I check the bottom one. What's 11 times 1? What's 2 times -6? Is 11 minus 12 -1? Can I solve systems? Now, again, be comfortable with both. Now, there is something we never did, guys. Don't bother writing down what I'm about to do. I just want to show you something. Have a look at this system I just wrote here. Now, every system we've been doing, we've been adding them together, yes? Because one of the coefficients has had the same number, but one's been positive and one's been negative, right? Do you have that in this case? What I just wrote over here. Do you have a positive and a negative coefficient that are the same? No. But remember, this method is called elimination, right? So as long as you can make one of the variables disappear, are you still okay? Is there another thing you could do to make one of these variables disappear? You could subtract instead of add. Is everybody with me? So if I just subtracted here, 2 minus 2 is what? 0. What's 7 minus 4? 11y. And what's 27 minus 6? 33. And see how I eliminated a variable there? By getting rid of one more step. So if they're the exact same, you can subtract as well. Is everybody cool? Yeah? All right, here's what I want you guys to do. I want you to work on page 239 here. I assume it's 239 in your book, yes? Yeah. I want you to work on that. You don't need to do all of it. I want you to do number 1. I want you to do 3C and 3b. And then I want you to do 6b and 7c and 7d. Please work on that right now till about 10 after 9 at the longest. I'd like it to be done before then because I do want to do one more thing today. Okay? You have to discuss any of them. Everyone's ready to go? All right. Now you will notice in your book, I gave you 2 of these puzzle sheets. Right? If you want to do them, go ahead and do them. But we're running a little bit short of time. If you feel you need some extra practice with this, then I would recommend doing those puzzle sheets. But if you're like, no, I got this, Myers. I'm good. I can do substitution and elimination and graphing. You're welcome to not. All right? But I would like to discuss, go on to page 241. Now remember, we're only dealing with lines, right? Right? So if there are any 2 lines on a graph, they can have one solution. Everyone agree? Okay. So if I asked you to graph these, what do you think is going to happen? If I put these 2 equations on a graph, what do you think is going to happen? Knowing everything you know about systems right now, what do you think is going to happen? They're going to cross somewhere, right? So let's go ahead and do that. It's going to be 4y equals negative 3x plus 24, which means y is going to equal negative 3/4 x plus 6. Everybody cool? And this one is going to be negative 3y equals 6x minus 33. So y equals 2x, negative 2x plus 11. So, Carlin, were you right in your prediction? He was absolutely right. They crossed, right? Okay, now, what can you tell me about those 2 equations that will allow you to understand that they are indeed going to cross? What is it about those 2 highlighted yellow equations that prove, without graphing, that they have to cross somewhere? Well, you only know 2 things about each of those equations, don't you? What are the 2 things you know? You know the these two equations here, what form are they in? Slope-intercept, which means what do you know about both equations? They both have a slope. What kind of slope? Same or different? Different. And they both have different y-intercepts, right? Which one of those two things, a slope or a y-intercept, determines whether or not those lines are going to cross? Is it the slope or is it the y-intercept? It's the slope that makes them cross, yes? So, we can make a conclusion. If the slopes of all the lines differ, we will get an intersection. And what does that mean? If I get an intersect point, what is that point? That's the solution. So if the slopes are different, we'll get an intersect point, so we'll get a solution. Everyone agree? Everyone cool? Yeah? All right, let's go to this next one. Here's another equation, another two equations. What would happen if I wanted to graph them? Well, I'm going to graph the first one in red. 4y equals negative 2x plus 12. Y equals negative 1/2 x plus 3. Everyone agree? Put it on the graph. 1, 2, 3. Negative 1/2, down 1, out 2, down 1, out 2, down 1, out 2. There's my line. Yeah? Blue guy. 2y equals negative x minus 12. Y equals negative 1/2 x minus 6. Now what do you notice? Graph it. Minus 6. 1, 2, 3, 6. And a slope of 1/2. What do you notice about those two lines? They're the same slope, which means they're what? Perpendicular? Parallel. What do you know about parallel lines? They don't cross, which means if they have the same slope, will they ever cross? No, which means will there ever be a solution? No. So what does that tell us? If slopes are the same and the y-intercepts are different, then what does that tell us? The lines are what? And if the lines are parallel, what does that mean? They'll never cross. So there's no solution. And you can tell that just by looking. You don't need to graph it. Oh, hey, those have the same slope and a different y-intercept. They can't ever cross. Everybody understand? Okay. Now turn the page over and do the third one, because there's only one other option. You guys should look at that. Set it up. Red line. Then the blue line. What do you notice here? They're exactly the same slope and exactly the same y-intercept. So if I graph them, what would I have? I would have a red line at 1, 2, 3, 4, 5 thirds, down to out 3, down to out 3, right? And then where would the blue line be? Right there on top of it. So how many times do those lines touch? Always. And what number is always? Infinity. So what does that tell us? If the slopes and y-intercepts are the same, then what do we have? The same line, which means they cross each other. They intersect infinitely. Everybody good? Yeah? Now, when I say is everybody good, I don't mean do you have it written down. Do you understand what's happening? If you got one line and the other line's lying right on top of it, then they're touching the whole time. Okay? Now, once again, what was the key to this lesson? What was the concept that we needed to find every time? What did we use? Slope. As long as we found the slope. If the slopes were different and the y-intercepts were different, how many solutions? 1. If the slopes were the same, but the y-intercepts were different, how many solutions? None. If the slope and the y-intercept are the same, infinite solutions. So, without solving these, how are you going to tell me how many solutions they're going to have? All you got to do is find the slopes and the y-intercepts. Everybody cool? So, that first one, find the slopes, tell me how many solutions. Are the slopes different? So how many solutions? 1 solution. I don't care what it is. I just want you to recognize that there's only going to be one. What about this guy? How many solutions there? I wrote it that way on purpose because most of you probably would have done this the same way. What do you notice there and there? It's the same. What do you notice there and there? It's the same. So those are the same line, aren't they? So how many solutions? Infinite. Now you guys are smart. This is a lesson, so obviously this is going to be the third one where there's no solution. Or is it? Dun, dun, dun. Check. Mr. Myers, why did you use P and Q instead of X and Y? Does it matter? Nope. Does it matter which one you make X and which one you make Y? As long as they're both the same, right? So if I'm going to solve for example, if I want to solve for Q, that would make Q Y, right? So negative 5Q would equal negative 2P plus 30. So Q would equal 2/5 P minus 6. Then this one, I got to get Q by itself. So that's going to be Q equals 4 over 10P minus 15 over 10. What do you notice there and there? They're the same. What do you notice there and there? They're different. So they have the same slope, but they're going to cross the y-intercept at a different point, which means they are parallel, which means they have no solution. Everybody cool? And that's it. If you go to this page, you would need to do just a couple. You choose.
What's the amount that we should do?
Well, let's have a quick look. To really, kind of get what we're doing here, I would recommend being able to do 4, 5, and 6. Anything past that is what you need if you want the A. Understand?
That's just to get it.
That's like bare minimum. That'll get you through with a C on your test. Everybody cool? All right.